everybody. Typically, I would do the other set of notes first and then this one second. But this one, I think we need a little bit more explanation before I set you free into the textbook work. So I'm going to do these, which are slightly more involved than these ones, but I did make a video for that one as well. But let's do this because I think this might set you up for more success on the textbook question. So just to start, in each equation, determine the value of a when n is 3. So this is just substituting what is known and figuring out what is not known. So we're looking for a, and we do know that n equals 3. So we're just going to substitute 3 for n and solve. So a equals 2 times 3 plus 1. So a equals 6 plus 1. A equals 7. Again, we're just going to substitute what is known. We know that n equals 3, and we're going to find out what is not known, which is a. So we're going to put in the 3 where the n is, subtract 2. A equals 3 times 3, subtract 2. So 3 times 3 is 9 minus 2. And finally, a equals 7. And our last one, again, we're going to substitute what we know. We know the value of n to find out what we don't know, which is the value of a. So 4 times 3 plus 3. A equals 4 times 3 is 12 plus 3. So a equals 15. Okay, so yeah, a lot of math is substituting what we know to find out what we don't know. And here we are just, this says that n equals 3, and so we're putting the number 3 into all of our n's and solving the equation to find the value of a. You can also, put the a back in to see if it's true. So is it true that, 7 equals 3 times 3 subtract 2? I mean, yes, it is true that 7 equals 9 minus 2, etc. So you can check if you'd like, just to make sure that you've done all of your calculations correctly. I was stalling there in case I went a little fast and you needed to write things down. So let's move on to number 2. The pattern in this table continues. Which equation below relates the figure number n to the perimeter of the figure p? I think the main thing to not get confused about in these is which one are your n's and which one is the p's. So when you're substituting for this, you kind of just got to guess and check. But you need to make sure that you're putting your n's in the n and the p in the p. So here we go. Let's try the first one. You kind of just, you can guess and check. Let's try to look for a pattern first, and maybe we can use that to start somewhere. We can notice that as this goes up by 1, plus 1, plus 1, plus 1, this goes up by 3, plus 3, plus 3, plus 3. So I don't know, this one has a 3 in it. Do you want to try it? We can see if that works. So the way that you can test this is just by inputting any of the values. So let's see, is it true that for 7, I'm just putting the 7 where the p is, does that equal 7 times, I'm going to substitute the 1 into the n, 7 times 1 plus 3. So looking at it already, does not look like it's equal. 7 plus 3 is 10, so it's not that one. Let's put a red. That's a no. We can try another one. I suppose we can just start. All the other ones have a 3 in it as well, so we could try any one of those. Let's try this one and see how we go. So the value P7, does that equal 3 times 1 plus 7? So does 7 equal, that's 3 plus 7, 10? Again, no. So that's a no. Let's try C and see if that works. I'll try it right here. Let's try for the value of p. 7, does that equal 3 times 1 plus 4? Oh, indeed it does. 7 does equal 3 plus 4. So that one is our correct formula. Okay, so I mean, interestingly, it's up by 3, and we have it being multiplied by 3. And if you notice, 3 plus 4 gives you 7. I don't know if that's going to be helpful for us. But I think the best way is to input the values that we have and see if it makes the equation true. Okay, I'm going to scroll down. If I'm going too fast, just holler out in class and I will pause it. Let's look at number 3. So the pattern in each table below continues. For each table, write an equation that relates v to t. Verify your equation by substituting values from the table. So let's look for some patterns first. T is increasing by 1 each time as we go up. And V is increasing by 5 each time, plus 5. So in our last one, even though you might be tempted, so we are looking for, let's say, V equals, blank T plus blank, something like that. So let's look. Let's try one. I'm going to think about multiplying this. It looks like we're multiplying this by 5 and then adding 3, because if you go 1 times 5, you get 5, and then we're adding a 3 to get to 8. If we try this times 5, you get 10, and then you add 3, you get 13. If you times this by 5 and then add 3, you get 18. So I'm going to think that our value here equals 5 times t plus 3. So you just got to examine it, look at how those relate to each other, kind of find the pattern and make an equation based on that. And then let's put in a value to check it. So let's try, this one right here. Let's try this one right here. So is it true that 13 equals 5 times 2 plus 3? So 13, does that equal 10 plus 3? Indeed it does. 13 does equal 13. And so that would be a correct equation for this data set. So it does take a little bit of investigation, maybe a bit of guessing and checking, but you always have this table of values that you can put in at the end and verify your equation. Let's do the last one. It's a bit tough, but we can do it together. Rachel takes care of homes during the summer while their owners are away on vacation, but house sitting. She charges $8 plus $2.50 a day. So 8 is our constant. No matter how many days she does it, the 8 is always the same. And this one is the one that is changing per day. So write a table that shows the charges when the owners are away for up to 5 days. So let's go here. Let's go C for charge and D for days. So we have 1, 2, 3, 4, 5 days. So for day 1, the charge is going to be 8 plus 2.50. So as we have the 8 plus the 1 day. So that's going to be $10.50. So you can think about, write an equation that relates to it. I've already kind of done this part. In fact, I think it's kind of helpful for this. I'm thinking about it as the charge equals $2.50 times the day plus $8, which is our constant. So for 2 days, you have the $8 plus $2.50 plus $2.50. So $8 plus 5, essentially, which is $13. For 3 days, you have the $8 plus $2.50 plus $2.50 plus $2.50. So that's $7.15. So that gives us $15.50. So now each time we're just going up by $2.50. So our next one would be $16, $18. And our next one would be, I think, $20.50. So for B, write an equation that relates to the charge, C dollars, and the number of days, they used N, that the owners are away. So I would say the charge equals $2.50. I'm going to use days. I already used the D plus 8. So 8 is the constant. 8 is always going to be 8, and it's the $2.50 that varies based on the number of days. So that's for, let's say this is A, this is B, and let's do C right here. What will the charge be when the owners are away for 14 days? So this is our D value. Let's go charge equals $2.50 times 14. So we're inputting it into the D where the days are, plus 8. So C equals, let me use my calculator, $2.50 times 14 equals 35 plus 8 equals $43. So charge would be $43. And our last question, D. How many days were the owners away when the charge was $33? So now we know the C, we know the charge. So 33 equals $2.50. And the D, the days, is the part that we don't know yet. So again, we're just inputting what we know to find out what we don't. This one is there we go. Scroll down a little bit. For sure, a little bit more challenging to isolate the D than it was to find out the C. But you need to do opposites to get it by itself. So we have this 8 that's currently being added to it. So let's subtract 8 on each side. So that's going to kind of zero that out. And we are left with 25. So 33 minus 8 equals $2.50 times D for days. Now to get the D by itself, it's currently being times by $2.50. So we need to divide it by $2.50. What we do to one side, we have to do to the other. And then this one, any number over itself is just 1, so we can cross that out. And the number of days equals 25 divided by 2.5. I can tell by looking at it that's 10. So the owners would need to be away for 10 days for her to make $33. I think she needs to up her prices. That's a pretty good deal these days. So anyways, I will tell you what textbook questions I want you to do. Thank you very much.